Hello, ladies and gentlemen. Welcome back. We're going to continue our look at the 2002 Grade 9 Pascal paper. We're on question number 13 already. Triangle ABC has vertices A12, B40, and C1, -4. And we're asked, what is the area of triangle ABC? And we're given our options here. So when we're asked the area of a triangle, my head starts a-humming with all the different ways that we can figure out the area of a triangle. And the most common one is the formula 1/2 base times height. So let's look at this picture. Is there a nice little base and a height we can use? Well, typically our heights come in the form of altitudes. And an altitude for a triangle is a line from a single point that hits the other side and makes a right angle. Well, we already have a line drawn in here that goes through our point B and hits AC, and it's the x-axis. And so I suspect that this is going to form a nice little altitude, and we can work out our triangle from there. Other options that I'm just thinking of off the top of my head, based on the picture, it really looks like we have a right angle at B. I don't know how true that is, but it really looks like we have a right angle at B. And so that might be something worth exploring. But I think AC and the x-axis are perpendicular, and that would work out just fine. So let's draw our picture and explore the question a little bit. So there's our y-axis. Oh, no, this isn't looking good. No, I don't like this so far. Let's draw this a little better. Much nicer, much nicer. So we have a point A up here, and A was at 1, 2. B's over here at 4, 0. It lies exactly on this x-axis. And C down here, well, C is also at has an x-coordinate of 1. So as a matter of fact, the line between A and C is just the line x equals 1. And that's parallel to the y-axis. And the y-axis itself is perpendicular to the x-axis. So AC is going to be perpendicular to the x-axis as well. And it passes through B. So I'm going to call this point, we'll give it a color, orange. We're going to call that point D. I have my triangle here. BD is an altitude of triangle ABC. It might be a little easier to see if we put it on its side. B, D, C, A. We get ourselves a right angle that meets up at B. So we're going to have our height, and AC will be our base. So we can use the formula 1/2 base times height. All right. So now we just need to work some things out. So D is on the x-axis. So D looks like something 0. Just like B is something 0 because they're on the x-axis. They have 0 for their y-coordinate. But D is also on the line x equals 1. So D has coordinates 1, 0. And we can add those into our little picture. So now to figure out the area of this triangle, I need to figure out the length of the base, so the distance between A and C, and the distance between B and D. So 1/2 base times height. That's 1/2 AC times BD. Well, because they lie on the line x equals 1, we really just need to figure out, to get AC, we just need the difference in their y coordinates. So we'll take 2 minus negative 4. And similarly, to figure out BD, we just take the difference in the x coordinates. That's going to be 4 minus 1. We're careful here to make sure that we're going to get positive values out because we don't want a negative area. So this is 1/2. 2 minus negative 4, that's just going to be 6. 4 minus 1 is 3. So this is 1/2 of 18, better known as 9. So we have an area of 9. Okay. Well, that is E. Our answer is going to be E. So we'll bubble in E, and then we're ready to move on to our very next question. And that'll be question number 14, and we're going to handle that in the next video. So thank you guys for watching, and I'll see you for number 14 on the 2002 Pascal paper in the next video. So long for now.